All right, so we're trying to find the inverse just based off of a function, right? These are the three things that we're going to need to do in order to do this on any question. There's the first example, there's the second example. Same idea on both of them. Okay, all of the functions are going to look like that sort of fraction. Why are they fractions? Because it says find inverses of rational functions. What word is in rational? Yeah, ratio, which means fraction, right? Okay, so that's what we're talking about. Now, what does it mean for something to be an inverse? Well, one thing is when we solve equations, something simple like this. Hang on, let's do this. If I asked you to solve this equation, you would do the inverse operations, wouldn't you? Okay, what two things would you do? You would add 7. Yeah, and then it says 5 times x, so you would divide by 5. Right? And you'd end up with 2. Okay, that's what an inverse means. We're doing the opposite of the operation. What does it mean on a graph? Let's look at a graph. An inverse on a graph simply means you're reflecting it over this line that I have drawn there, where it says y equals x. You're reflecting it over that line. What does that mean? That means every y becomes the x coordinate, and every x coordinate becomes the y coordinate. All right, so let me show you what I'm saying. Let's say there's one point here, 2, 4. Okay, what's the inverse of 2, 4? I don't need to make them negative. I just need to switch them, right? And that's a reflection. That's an inverse. If I do it with an entire graph, here's what it might look like. Here's an example for you. Let's do x squared. Now, I'll have to do this with 2 separate graphs because technically square root is only a half a function. Okay, talk about that another time. But the inverse of squaring something is square rooting something, right? So what you'll notice is there's a reflection going on there. If I zoom in, they have the same points, but they're just switched. For example, right here. Whoa, there's a point at 4, 2. I wish it would just click on it. Okay. That means over here there should be a point at where? 2, 4, which there is right there, right? Those two things are inverses. So that's what we're doing when we're talking about finding an inverse today. All right. Now, how do we do it? Here's the process. First thing is the reality of the situation is we don't actually do step 1 first, but I've taken a shortcut for you. I normally did this with like 4 steps. But here's what actually happens. This is a y, right? A function is a y coordinate. And then since we're trying to find the inverse, what do we do with the x's and y's? We switch them, right? So I just took that part out of the equation. So first of all, what we're going to do is we're going to rewrite the equation like this. We're going to plug an x into there, and then we're going to put a y where? Wherever there's an x. So now our equation looks like this, kind of all in one step. It says x equals 9y plus 4 over y minus 7. If we're finding an inverse, we're switching the x's and y's. All right? Most of the work, almost all of it, is in step 3. All right? How are we going to do this? What we have to do is solve for y. The problem is right now there are how many y's in the equation? There's 2 of them. So this is kind of a little bit of advanced algebra here. So the first thing to do is think of it like we're cross multiplying like we just did. Okay, so this is how we're building on the last thing we did. What's underneath the x? There's a 1 under there, right? So now we're going to cross multiply. Throw that up there, throw that up there. Let's write down what we have, okay? So here's step 3. We're solving for y. Now, keep in mind, we're not going to get an answer that is a number, right? We're going to get a new equation. All right, what do you think the next thing to do is? Yeah, go ahead, say it. Yeah, distribute. So we're going to do this wherever we have to. Usually it's just on one side. All right, so when I take x times y, it's not like anything fancy. We just say that it's xy. All right, x times -7, -7x. All right, so that was when we distributed. I need to move this thing down. This is where our answer is going to go. What are we solving for again? Y. All right, so I'm going to make a little note here. We distributed, right? Distribute. Okay, next thing to do. Everything with the y on one side. All right. Everything else on the other. So everything that has a y in it, we want to move to one side. I usually move it to the left side of the equation. Here's what I mean. All right, so we're going to have to move stuff around. That means we got to do algebra. We have to do the opposite if we move it, right? Okay, so everything with a y, I'm going to move this direction. Everything with a y moves over there. So that has a y and this has a y. I want to move it to the left side. So what am I going to have on the left side now? Tell me. Yep, and then minus 9y, like that. I want to move everything else to the other side. Okay? Everything else includes this in the 4. That means this needs to go over there. So what's it going to say on the right-hand side? 7x plus 4, or you could say 4 plus 7x. It doesn't really matter, right? I'm going to write it like the order you guys said first. I like that. 7x plus 4. All right, we still have an issue because there are two different y's, and we need to solve for just one, correct? All right, let me show you something to help you understand what's going to happen next. Tell me, what you'd normally do with something like this. Distribute, right? And then what if we started with this? What if I said, hey, how could I rewrite this? It's something we even did in the last assignment. What do they have in common? 3. And what we did is we just rewrote the same thing 2 different ways, didn't we? But if you notice, up here in the top part, how many 3's do you see? 2. In the second part, how many 3's do you see? So, how many y's do you see? How can we make it so there's only one? Factor it out. Let's go. Very nice. All right, so now let's factor this. Factor out y. Keep going. What's that mean? Right, we just took the y out. See ya. Now there's only one y left, right? And we're finding the inverse. We're solving this equation. When I write y out in front like this, what is it doing? It's saying y is doing what with the x minus 9? It's multiplying. How can I undo multiplication? Divide. So what I'm going to do, I'm going to divide that whole thing over there on the right by x minus 9. And that's my answer right there. You're going to type that in this little box. Okay. This little thing that you see here, this g and then -1, that's not an exponent. All right, sorry, let me move it up for you. That's not an exponent. This means inverse. This means inverse of g. So it's the inverse of the function. It's a symbol. If you remember on your calculator from geometry, you guys did inverse sine sometimes, right? And it said sine -1, right? Or sine or cosine -1. That didn't mean to the negative first power, it meant inverse. So that's what this means. Okay. So if you notice, it looks kind of similar. Oh, geez, that's not what I wanted. It looks kind of similar to what we had in the beginning, right? Just the pluses and minuses kind of get moved around. What we multiply by is a little different, right? But otherwise, it's a very similar looking equation. You're going to use that process every single time. Let's try this one here. I'm going to pause, let you try it out on your own real quick. All right, so I went ahead and changed everything to x's and y's like we said in step 1 and 2. So now I'm going to put this thing over 1. All right, now we have to cross multiply, right, people? Okay, so we've got this. There we go. All right, so from there, next step, distribute. So okay, looking a little funky. That's okay. Everything with a y on it to one side. So what's that include? That includes this and that on one side. Doesn't matter which way you move them. All right. Not even for a second. This time for funsies, I'm going to move it to the right. Okay. So let's say I move this over there. Means on the right side, it would be positive 4y plus 5xy. Everything else on the other side, right? So here, that over that way. So that means when I move this 3 over to the left, it's going to say x minus 3. There we are. What's the last thing to do? Factor that sucker out of there. All right, so over here, they each have a y in common. It's not really the last thing, I guess. Last step. Yeah, divide that son of a gun. Here we go. So this is y times, right? So which one goes where? Yeah, this goes over that way, right? Goes down to the bottom over there. So y equals x minus 3 to the 4 plus 5, or sorry, to the divided by 4 plus 5x. There we go. You want to see what it looks like when we graph them both? Okay, so 3 plus 4x. Let's graph it. Oh my gosh, what the heck did I do? 3 plus 4x. What? Over 1 minus 5x. That's the answer. X minus 3. Oh my goodness. There we go. Whoa, I did not mean to do that. Sorry, there we go. Now watch what happens when I chart this thing. There's our reflection, right? So take a look at the green and the black, right? You see how this part reflects to there, right? And then vice versa, green reflects over that way to that black line there. They're inverses, yay. Guess how you can check yourself? Put them both on Desmos. Put the original on there and put your answer on there. Just like I did there. There should be some kind of reflection in this manner. It's kind of cool. All right. Let me assign it to you.